Hi, thank you for this invitation. I would love to present my work in Jordan. This example is a small mosque near the blessed tree location. Some visitors came daily to visit that location. This totally built from stone with the old technique. We have different domes. I will start here. This is the blessed tree. In area, there is no any other tree like in 10 kilometers. So there is like a historical story about it. Here, the location of the mosque, I think it's the mouse not present, and down is the blessed tree. It's away from Amman, from the capital. It's at the northeast near the Iraqi border. So here the plan is very simple. We have 4.5 meter diameter of 3 domes. The central one on the middle, which is directed to Qibla or Mihrab, Mecca. And right and left, we have like a small shallow domes or sail vaults. And the entrance opposite of the Qibla direction. Here the plan at the drum, at the top of the dome, we can see the squinches and twin windows, and the top view of the 2 small domes, right and left, and the vault on the north direction. This is the top view. Here, one of the section, longitudinal section, we can see at the middle the central dome set on 2 not wide vaults, right and left, and the shallow domes on the sides. To minimize the thickness of the wall, for the shallow domes, we make like small niches. We train, I trained like 2 group of craftsmen, builder on the side. And we train them from scratch. We don't have that experience to build the domes in Jordan anymore. Here you can see 45 degrees section on the left to see the thrust and the forces, how it goes down through the squinch. On the right, normal section to see the dome behavior and the forces. This is cross-section through the entrance vault and the mihrab on the right, and then the dome on squinches. This is the pre-designed graphics. You can see the top view, and I cut the model through different levels to see the walls and the sections. Here another graphics to see what we are going to do. Some of the treatment, it's change during the construction, like the main arch here, to carry the sail vaults, I divided to 2 small segmental arches. Here another sections. This is some extra details graphics. Here the sail vault on the right, we cut it from the 45 degrees to see the profile of the semicircle dome. Here it's more clear. If this is the shallow dome or the sail vault, we cut it from the 45 degrees to see the profile of the circle. Because if you cut it from the middle, you see just like a small segmental part. You didn't see the circle coming from the spring line to the top. Another details here, the calculating the volume of the dome itself, the shuttering and the thickness of the dome are increasing when you are going down. And we make like revolving profile to guide the builder. Here, this is the rendering or visualization of the project from the south facade. And this is the real image after we finish the construction. We can see tracing of the mihrab at the middle and two buttresses right and left to carry, helping the forces to go down for the main domes. And we imitate the minarets because we don't have any vertical element with those small four corners. This is the exterior of the project. We use local stone. During the construction, on the right, we can see the main dome after we finish with some tile pattern at the middle. And here on the left, also, while we are finalizing and finishing the dome, this is the entrance facade. Here we have like niches on the left to put the shoes and something like that. So we cut it with the intersected vault to minimize the load going down. We have like rainwater details carving from the stone. That's the central dome interior views, like a bottom view to see the four squinches and how we converting the square base to octagon shape, then to convert it another layer to have it like a 16-fold to set the dome on it. Those extra interiors. Now here I will explain how we do and build the sail vault. First of all, we have to build 4 circular walls, half-circle walls in the 4 sides as a first step. And here to minimize the load and have decoration and some seats, shelves, we get 2 niches with segmental arch. So we build in each corner that half round wall in stone. And the step after that, we start closing the corner to have like a pendentive details to find out the circle at the middle. So always we have the guide to from the center of the dome and spring line level. That's we showed before in the 45 section cut. So the center, if you have the section from the 45, you will get like half round section. So we use it as a guide. Closing the corners until we reach the top of that semicircle walls, step by step. Then after that, we start continue the building the dome itself. Here, the stone with the lime, it's not easily to get dry. So what we did for the upper third of the dome, we put like a shuttering or formwork from the polystyrene, and we fill it by sand. Then we continue the last third of the dome. And here, after we finish, this is the result from the interior before adding the joint, the lime for the joints. And this is the result for the shallow dome. For each shallow dome, there is like a 3 walls, exterior 3 side walls, and the fourth one is a pointed arch, pointed vault carrying the load from the main dome or central dome also. We use the small tile patterns using stone also and basalt, the black one available on the area. Here, the dome on squinch. After we finish the 4 walls, we have to start the base for the squinches. So you have to go cantilever. The detail is very simple. We just got like 3 layers courses of stone, step by step, to get the corner where the squinches will sit. That's a bottom view for the squinch, and this is how we put like a polystyrene shuttering to hold the stone. This is the details of the squinch. And after we finish the squinches, we have like a twin small windows to cover the other sides to have the octagon shape. And this is the view before we start the building the dome itself. The site is very, very hard. There is no electricity. It's out of the city. So everything we're trying to use like manual tools. We have generator just in case we have to do something with the... Here, after we finish the ring, we start the dome. So we get this profile rotated on the center to get the profile of the pointed arch, pointed dome. And we minimize the load on the above the squinches by those 3 steps to get the octagon shape and the round in the center. We have here the tracing of the 4 small windows above the twins down through, cutting through the dome itself. We use basalt base just in case there is like a rain or something coming. Here, a drawing for the tile pattern, what we did it in, it's very, very simple. We use the unit, which is 25 centimeter stone, which in general, in Jordan, they are use it for the cladding. We use it here as a floor. And the black is the basalt. more images for the squinches. And during the construction, we invite the architecture students from the universities to came and seeing the construction, and that will make him find another solution that you can build without reinforced concrete. And they get more excited and coming a lot of time to visit all the stages of the construction. On other projects, we have the student on the summer, they came and cut the stone and trying to help on the construction to learn more. Here's some reference from the area. We have some historical buildings in Jordan by stone. Here, this is the squinch, and trying to sketch over the image how we convert the square shape to an octagon, then 16-fold to get the round base for the dome. This is the small explanation for the mosque. I have different project. If there is time, I can pass by also. And what do you think, Alejandro? Here, this is the one of the first projects. I did it in Jordan. We finished the tile pattern, and we cut all those stone on site to get that floor pattern for the courtyard. Here, another floor patterns for the inside. There is like the Arabic Ka'a, and we use the travertine local one and the basalt with the limestone. Another dome squinch details. Here, this is also another dome on squinches, but more complicated than the mosque dome, with some like stalactites details at the corner. It's not clear here. And here, how we when you have the dome on squinch, you have to convert the rectangular base, which is the room itself or the space, the red color or red square, converted to an octagon shape, which is during or through the squinches or through the pendant, different depend on the dome itself style. Then I have another one like to convert it to 16 star or 16 fold. Then you will start the dome. And here, this dome carried on arches on dry technique. We didn't use mortar. So here the stone just adjust each stone on each other. We don't have any mortar on this sample. This is a computer detail for that dome. This here, the shallow dome also. The details on before we start the dome, this is we have like 8 opening on the dome above the squinches level on the drum. And here the details where we change the octagon to 16-fold by those small piece of stones, and then we have that window within the dome itself. So we used here different kind of stone. The natural one, which is just came direct from the land, we just dress it a little bit, and the other one is just cutting on the saw. Here, this Ka'a, the dome, carried there is like a two catenary arch, right, a vault, right and left to help it for the forces. So we have to build it first, then we construct the dome. Here the squenches, how we do it, we have like a normal arch at the octagon side, then we build like a half dome to carry the squench. Here another example of the sail vault. We built 4 sides, half round, then we close the corners. This rendering, cross vault details, we built 4 arches, and we use that like a crane with electrical motor to carry the heavy stones and put it on place. Another cross vault example. Here we have tried to build the Nubian catenary also on the left side. Those are the students came and help us on cutting the marble. And that's it.
Thank you very much for this presentation of this wonderful work. Questions, comments, preguntas, comentarios. Si alguien quiere preguntar y no se atreve por el idioma, yo puedo traducir también, no hay problema. O digo porque no sé si no cómo lo podríamos hacer, ¿no? Para que sea ágil. Vamos a lo que tengáis auriculares, con lo cual sería más fácil. You have also translations.
Thank you for a very interesting presentation. I would like to know how these buildings behave when it comes to climate and weather, and how they're like to be in during winter and during summer, and if it's raining or not. Because obviously this is a traditional method of building, but could you also say they're eco-friendly regarding use of air conditioning or heating or those things? How do they work as structures to be in throughout the year in the climate? Thank you.
Actually, it's not been tested yet because one of the project is my own house, so we didn't finish it yet, and the mosque also still didn't. They open it regarding to some situation in the Middle East. You know that. In general, we have those thick walls, and we feel it. With the labors while we are working. In the winter, it's warmer inside, and even in the summer, we didn't finish and close the building. We feel it. We feel the difference in the temperature. But I have to test it later after we finish and make a real calculation. How much we can get like a delta different in summer and winter.
Buenas tardes, enhorabuena por su proyecto. Una pregunta, ¿qué le motivó a usar el arco catenario? Solamente era eso.
The reason of that, I worked for a long time with my mentor, Professor Abdul Wahid Al-Wakil, and all my experience with him, he is building with the brick, and the Nubian vault, which is built without shattering, that's coming from the Nubian civilization, and Hassan Fathi, he brought it back to alive by his project, and Abdul Wahid Wakil, one of his students, and that's why we are using that catenary arch. But in general, this catenary arch should be work like what Anna Maria did in brick or in Adobe, not in stone. Here, I'm trying to learn different kind of vaulting and ceiling on that project. So I wouldn't like repeat any ceiling I did. So I keep trying and discovering what is the better for the construction. So that's the reason why I use it.
In a way, I understand that your own house is your own testing ground. You're testing different systems.
You mentioned that to build these buildings, you had to train your craft people in stonemason techniques. I found this very interesting because, for example, here in Spain, it will be impossible to find an architect who can actually train masons to build the process. So can you elaborate a bit more on how is this process of training the stonemasons? And also afterwards, once you have trained them, if these people are working with you in other projects, or if each time you had to train a new group of people?
In general, it's like what you said, it's hard to train people, but I told you we have like 2 teams. We work on those 5 projects on stone in Jordan, and the background of those carpenter or builders, they can deal with the wood to create the shuttering or the formworks. For the builder, they can build the stone walls, but they don't have any knowledge how to make the stone ceiling. So when you stay on site daily basis with the laborers and try to simplify the order for them, this sequence, it will make the work easier. And after you finish 1 or 2 example, they will get that experience from you. Like when I build a shallow dome, first one, I have to put the center and stay with them to teach them how to build like a half round. And they keep asking why we have to build the wall like this. So then when they finish, close the corners, they understand that why. And when they later on finish and close the dome, they understand the steps. So the next shallow dome, I did it in another project. I just give them the spring line and they easily follow, and they can do that. So it's not like an impossible mission. If you as an architect or builder have the knowledge and try to simplify it for the laborers and craftsmen and carpenters on site.
Thank you.